Hi guys, I'm Peter Ryan, Mechanical Engineering Lecturer at Dundalk Institute of Technology. In this video, what I want to cover with you is an introduction to 3D printing. Okay? Creating the file in particular will be the focus of this video. Okay? So if you want to 3D print something, the first thing you have to do is draw it in a CAD package on your computer. Right? You then have to transfer that file to a slicing software that tells the printer exactly what way to print that file. And we have a lot of settings we can turn on and off depending on how we want to print it or what our printed file is for. Okay, so let's have a quick look at the steps and then I'll do a demonstration of each aspect. Okay, so the steps to creating a 3D object. The first thing we need to do is create a 3D CAD model of the part. Right? And we're going to do that in SolidWorks today, but there are lots of other CAD softwares that you could use. Some of them are free. Okay, so it all depends on what you have. Right? So you may have some in your school that you can use. You may have SolidWorks or Creo, or you may need to download a free version yourself if you want to do this. Okay. Step 2 is to convert that CAD file into another file format, right? And that file format we're going to use is an STL. So that's just a wire mesh file that we can then transfer to the software that comes with our 3D printer. Okay, so step 3 then is to open that STL file in our 3D printer software. Okay, and again, this software will come with the printer, or you can download a free version and called Cura or another one and use that with any printer or with most printers. Okay. So step 4 is to use our 3D printer software to create instructions for the 3D printer. And this is where we tell the printer all of the different settings we want to use. So how many layers do we want to break the 3D model up into? Okay. So how fine should that be? And that depends on the detail that we have that we want in our 3D object. Okay, so a very detailed file, a very detailed object might need a very fine slice, right? So we might have a slice every 10th of a millimeter, right? But a much less detailed, like if we were just printing a cube, for instance, we might not need that level of detail at all. So we could get away with maybe 0.3 of a millimeter, okay, or 0.4 if we could do that with our nozzle. Okay, so that's where we set all the different settings and that in the printer, and we'll talk about that later. Step 5 is to save the file and send that file to a printer, and I'll show you how to do that as well. Okay, so let's make a start. So again, we're going to use SolidWorks to draw our 3D part. Okay, so let's open SolidWorks. Okay, I'd already started opening it because that can take a few minutes. So when you open it up, you're going to get this welcome message or welcome window from SolidWorks. So over here, you can start a new part, assembly, drawing. Down here, you have the parts that we've already created. Okay, so you probably won't see anything here. So I'm going to go to part to create a new part. Okay, so the first thing I'm going to do is just set visibility for my planes on so I can see them. Okay, so right now you can see the top plane, the front plane, and the right plane. So these are just my X, Y, and Z planes, and that's where I can draw my sketches and just to orient my model. Right, so for this part, we're just going to create a simple part on the front plane. Right, so I'm going to click on my front plane. I'm going to right click and I'm just going to press this button here. And that just brings my view perpendicular to that plane. Okay. So the first thing to do is to create a sketch for my part. Okay, so new sketch. Right. Down here is my origin. So 0x, 0y, and 0 in the z-axis. Right. So I'm going to start a corner of my part here. Right, so let's just draw a cube, for instance, okay, or a square in 2D. So we go to our center point, or our origin, and we'll just draw a square. Okay, I'm going to press escape just to get out of that, and I'm going to go up to Smart Dimension. Okay, and Smart Dimension allows me to click on features and specify the dimension for that feature. So if I click on this side here, it's allowing me to specify the length of that line, and I'm going to make it 30 millimeters. Okay, in this one, again, I'm just going to click and I'm going to call that 30 millimeters as well. Okay, now that's not the only way I could have specified a square. Right? I could have specified that this one was 30 and then just said that this was equal to that. Right? And if you've used SolidWorks, you'll be aware of that. But today's lesson is not about SolidWorks. It's just about creating a 3D file. So we'll just keep it simple and do things this way. Right? But there are more efficient ways of specifying these shapes. Right? So if I wanted to change this square, I could just change this now to 40. And if I had it set up right, this one would automatically change. But I will have to manually change these two because I've separated them. Okay. So the next thing I want to create is I want to create a hole in the center here. Right. So I'm going to go up to Circle. And I'm just going to click it here somewhere roughly in the middle. Doesn't matter for now. Okay. And again, we're going to use our Smart Dimension tool. And we're going to set a diameter there. It doesn't really matter. Let's set 12. Okay. I'm now going to click on the center. And I'm going to click on this. And I don't have to press Control or anything like that. Just click on this point and then this one. And we're going to make that half of this height here. So 15. Okay. And again, I'm going to click on my center and this, or the other way around. I click on this one and then the center. And that will specify this dimension. Okay, so we want that to be 15. So it was a little bit off when I was placing the part by sight. So we'll just make that 15. Okay, and that's my 2D part. Okay, so all I need to do now is just exit out of that sketch by pressing this one, not the X. Okay, and I can just look quickly at what we've created. And if I look at the front plane, I've created a sketch of a square with a circle in its center. Okay. I now want to drag that into a 3D shape, right? A cube. So I need to go to Features, and I'm going to go to Extruded Boss or Base, right? So I'm going to click on that, and because I had the sketch already clicked, it has automatically picked up that the sketch is what I want to use. Okay, and you can see that that's taken the sketch, and as I look in this way, it's extruding the sketch this way, right? So to the left. So I can change that by dragging it back this way or this way, okay? And I can change the length or the direction by just dragging on the arrows. But what I'm going to do is I want it to extrude both sides of the plane. So you need to go up and have a look here. So direction 1 is already selected, and we can set that to 15 millimeters. Okay. Direction 2 is not selected, so I'm just going to hit direction 2, and now it's extruding the opposite direction as well. But I have to specify that length separately. So I'm going to specify 15 in there. Okay, so that now the front plane's in the center of these two, and I can just press the green arrow up here, and now my sketch, or my 3D sketch or 3D shape is complete. Okay, so I have a 30 mil by 30 mil by 30 mil cube with a 12 mil diameter cylinder cut from it. Okay, so this is the shape we're going to set up for 3D printing first as a simple example. So the first thing we need to do is save this CAD file so that if we need to change it or do anything later, we can. So we can go up and we'll save as, and we're going to call it cube. Okay, I already had a part called cube 1, so it's prompting me to call it that, but we'll just call it cube, and we'll press save. Okay, so it's a SolidWorks part, and we press save. And that's my SolidWorks model complete. Okay, so I think I saved that on my desktop, so I'll just go back to my desktop and we should be able to see this. Okay, so right there in the center, that's my SolidWorks file called cube. So that's step 1 complete. So all we need to do now is go back and have a look at step 2 and see what we have to do next. And step 2, again, was to convert that file to a file type that my 3D printer software can recognize, which is called an STL file. Right, so it takes that solid model and turns it into a wire mesh. Okay, so let's go back to CAD, right, SolidWorks, and we're just going to go File Save As. It's as simple as that. File Save As, and select the part we want, or the type we want, which is an STL file. And we'll leave it called Cube. Okay, and we're going to leave it in, I have it set to my desktop, but somewhere where you know it, you can set up a folder if you were going to create a part like this. So we press save, and I get this message pops up and it shows me my wire mesh, right? I have a very simple part, so the mesh will be quite coarse. And I'm just going to hit yes. So it has broken this part into 160 triangles, right? So that's my triangular mesh. Okay. I'm going to press yes, and it just asks me to confirm what I want to export. So I'm selecting all bodies, right? But if you had different parts of that, you might select the ones you want. But for us, we'll just take everything. And that should now be exported, and I should now be able to see that file on my desktop. Okay, so Cube. Mine appears with a Cura symbol, so a C. That's because I have the 3D print software set up to be the default for these type of files. But for you, it might just be a 3D object or something, right? Depending on what way you have it set up. Okay, so just that's why it's important to know the name that you've set. And if you can't find it, you can just go down here and search Cube, and you'll find where you have it set. Okay, so that's step 2 complete. Okay. Step 3 then was to open the STL file in our 3D printer software. Okay, and the 3D printer software we're going to use today is called Cura. And it's quite popular, right? And that reason for that is that it's free, and also, maybe more importantly, it's open source. Okay, so the code for developing it is actually released so that people can make alterations to the code and have a slightly different, customized version. So a lot of the 3D printer companies, particularly coming from China, are using Cura, or they're using versions of Cura that they've customized themselves. So again, that's why it's quite popular. So that's what we're going to use today. So let's just close that down, and we're going to open up our file. So I could just double click on Cube there, and that will open it because I have it set that Cura will open these. But just in case you don't, we'll just open Cura here. So you'll see Ultimaker Cura. And Ultimaker is just a company that developed Cura. They're a 3D printer company that make, quite high-end, I suppose, printers. So the type of printers you would have in universities or schools, maybe not the type you would buy yourself at home. Okay, but they have made it open source, so lots of other companies for cheaper home type 3D printers will also use this. Okay, so this is how Cura will then open. Okay, so what you see here is a 3D representation of my 3D printer. Okay, so this is the bed of my 3D printer. So it's basically the plate where my 3D print is going to sit, and all of the layers are going to be extruded on top of that bed. This is my one of my axes, so my X axis and my Y. I mix it up, but I think this is X. Let me just check. I'll check in a second. Right, when we bring it apart, we'll be able to check that. So I think this is X, this is Y, and then Z is obviously the height. Okay, so different printers will have different size print beds and different heights that they can print. So collectively, that's called the print volume. And again, that will depend on printers. Okay, some of the cheaper ones you'll see online, and that will have smaller printer beds. Some of them you can get much larger for larger printers. Okay, larger prints. So the first thing we need to do when we open up Cura is to select what printer we actually have. Right, so you can see this is an Ultimaker 3 Extended. Okay, I also have an Anycubic i3 Mega set up on this, so that's my own printer at home. This is the printer in DkIT. So some of you, depending on which kit you got for the robot arms, you may have got one printed on this printer or some printed on this, probably mostly on this one. So it doesn't matter, just to show you the difference. Right, so for the Anycubic, it's a more basic representation. So again, it has the right X, Y, and Z dimensions, and that's the main thing. Okay, so I'm going to go to the Ultimaker 3 Extended, which is the one in DkIT. And as well as changing the print volume, selecting that different printer also brings up different settings, default settings here, and different options. Okay, so it is important that you have the correct printer selected. So a file that I create for my Anycubic i3 Mega won't necessarily work on other printers, right? And generally won't work. So you need to know what brand and model of printer you're actually creating this file for. So that's the first thing, okay? Because different printers have different options, and some of the things we select here may not correspond to the options that a different printer has, right? So when it transfers our drawing, right, our 3D model, into a set of instructions for the printer, you need to make sure that everything has matched up, and you do that by making sure you have the correct printer selected. Okay, on an Ultimaker there are two extruders, right? The part that injects the hot plastic out onto the print bed in layers. So you have this one, so print nozzle 1 and print nozzle 2. Some printers will only have one, so the Anycubic only has one. All right, and again, the Ultimaker has two. So you just need to make sure that if you want to print, for instance, from nozzle 1, if that's where your material is, you just need to make sure that that's the one you're on, and that, so over here on this option, I'm selecting 1, okay, but over here I have my material put in there. So for our material, we're using PLA, right, which is the more common material for home printers, and that it's the one that most of the cheaper printers will use. So it's non-toxic and it's more ecological, but it's made from vegetable oil. Okay, so green PLA is the one we want, so we can go into Ultimaker and we can change our material here. So again, we're using PLA, so we can set to whatever material we want. Okay, so green is the one we have in the printer at the moment. Don't mind this. This is just a thing that will pop up if I've made any changes in here. So I'll just discard and go back to the basic settings. Now, the print core, there are different options in the Ultimaker. There's two different types of print core, AA or BB, and then a few different sizes. So the more common size and the one that would normally be used is 0.4 of a millimeter. And that's actually the diameter of the extruder. That's how small the extruder is. And AA is the one we use for PLA. So that's something you would need to know. You won't have that option on a lot of printers. They just have standard nozzles. Okay, so that's all we need to set up now for our Ultimaker. The next step is to bring in a part. Right, so I can just go up to this import folder, and I can go to my folder. So I'm using desktop, and my part name is cube. Right, and I just open that, and that brings my cube in and places it on the bed. Okay, it has automatically placed it in this orientation and it's sitting on the bed. Okay, so if I click this, it then brings up a lot of options here, right? And I can see that my Z coordinate, so this one here is all the coordinates, my Z coordinate is 0, right? And that's important because if that was anything other than 0, my part, I don't know, it's maybe not going to let me change that, is it? Okay. Maybe I can do it this way. Okay, so it's automatically snapping the model back down to the bed. So if I try and hover that up there, it's dragging it back down. Okay, that's a setting that I've turned on in the background. If that's not turned on, sometimes you will see the parts are floating, or more commonly that the part is actually half. So okay, so I can do that one. So see the way the part has now sunk into the bed, right? If I print that now, it's only going to print this top part here. It's going to exclude everything else underneath. So you do need to make sure that you have that at 0. Okay, and again, generally that will happen automatically, but sometimes that may not happen. Okay, and I was right earlier, X is the red axis, so this is the X, right? I can see it there, they're color coded, same as this arrow. Y is green and Z is blue, right? So that's my positioning of my model, right? I can also change the scale, right? If I wanted to make this bigger or smaller, without going back into my CAD file, I could just scale that up to 200%, okay? And I could scale it back down to 50% if I wanted to make it smaller. And that's fine for a part that's not part of an assembly or anything like that. But if I had a part that was part of an assembly or even had moving parts in it that I was printing all in one go, then I would need to be careful, because changing this would also change the gaps and the clearances that you have in your model. So a better way of changing the size of your model is to go back into CAD and physically change the dimensions in there. Okay, so be very careful about changing the dimensions in here by just scaling. If it's just an ornament or a decoration, right, it makes no difference. So we can scale it up and down all we like. Okay, but if it's a part for an assembly, you're better off to go back in and change the dimensions or scale it in CAD. Okay, so you can make sure the clearances are the same. So that's my scaling. There are other things in here. So I can change the rotation, right? So I can rotate that all around there. I can do the same here, right? Okay, and it does kind of snap to certain angles. So it'll snap to 90 degrees. So I can place it on its side like that. Again, I can use the green one, so I can do the same. Okay, but now I have the hole horizontal. So when it tries to print now, any of the material above that hole will just fall down into this hole here, right? So you would have to use some kind of support material in there, but we don't want to cover that today. So the easiest way for us is to print it the way it came in, right? So I'm going to go to the reset button here. And now, if I look down on this, right, the hole is obviously pointing vertically. So there won't be any printed material going over that hole that would fall into it. So that one is fine. We'll be able to print that the way it is. Okay. So we'll put that back where we can see it. I could select surfaces as well. Another one I can do is I can select particular surfaces to put horizontal if it didn't come in right. So I can select that one and it will put that horizontal. If I click the top one, it'll put that horizontal. I can click this one, it'll put that on the bottom surface or horizontal. So you can do that if you have a more complicated model and it doesn't come in the right orientation. But generally, for simple shapes, they will come in. If you've drawn them the way we did, they'll come in like that. And it will pick a surface. But should they come in at an angle, you would use these to make sure it's printed right. Okay. We won't look at the other options, right? So they're the three main ones you will need to set up simple files. Okay. So we're almost at the point where we could just print, right? So we do need to go back up. So when you open this, perhaps this won't be visible. So you'll need to click up here, right? So without knowing any of the settings, first of all, I can just look at this, right? I have fast 0.2 of a millimeter, right? So that means every single layer is going to be 0.2 of a millimeter high. So we can see this inside in our preview. Oh, I haven't done a slice, so we do need to hit the slice button. The older version, you didn't have to do that. So slice, right? That has now sliced our model into 0.2 of a millimeter layers. Okay, so that's 30 millimeters, right? And we have a layer for every 0.2 of a millimeter. So you can calculate your number of layers, right? Or you can read it over here. So it's 149. 149 layers. And we can use this to see the different layers. So let's go down to the very first layer. Okay. So our very first layer, right, you'll see is actually bigger than the cube. So I have these extra lines here. And what they are is that's called a brim, right? So in this file, it's set up that to help this model stick to the bed, I've printed extra layers around to make the base a bit wider, and that's just to help the model stick to the bed. Right? For this model, it's probably not necessary, but if you have quite a tall part to print, or it's quite narrow on the bottom, then you would need to use the brim. Right? For instance, if this hole was almost 30 millimeters, so it only left a small bit of material around, then there'd be very little actual material on the cube actually on the ground, on the bed. So you would need this brim to help it stick, because if it doesn't have enough surface area to stick, what will happen is as you print up the higher layers, it will come loose and your print will fail. Okay, so all of that material will have been wasted, and also all the time that it has taken to print it. Okay, so 0.2 millimeters is generally the standard print. Okay, so we're not going to change that. Our print time is 52 millimeters, or 52 minutes, sorry. Right, and our amount of material that we're using is 13 grams of PLA, or 1.59 meters of our roll. Okay, so that just tells you your stats on how long your print will take and the amount of material, and that's important when you're designing something to be 3D printed, that you understand how long it will take and how much material it will take. Okay, because that's ultimately that will tell you your cost. Okay, so the only other thing I suppose we need to mention is that we're not printing this cube solid. Right, so you can see that first layer is solid. Right, if I go to my second layer, it's also solid, and there's cross patterns. So if we go down one, you can see the diagonals are going this way, right, the print lines. And when I go on the second one, okay, my printer has actually started printing this way, right? And it does that for strength, right? So if we just continuously printed in the same direction, you wouldn't get good adhesion between layers, right? They'd be weak. So this makes it very difficult to snap even a thin sheet of this material, right? So like plywood, it's keeping the grain alternating up and down. So that's the lines. As we go up, the lines alternate 90 degrees every time. Okay. As we get up to the fourth or fifth layer, I think it's the fifth, maybe the sixth layer. Yeah, so the sixth layer, we go from a solid layer into a meshed layer, right? So it's, rather than joining up all of the lines and having a solid surface, this time we just have a kind of a hatched surface, right? In this case, I have triangles, and if we go up next, it builds up on those triangles, and that's to save material. Okay, if we had this all solid inside, right, for greater strength, we would use a lot more material. So for making parts on a 3D printer, you use percentage infill. So this is probably something like 20%, and in fact it says it there, so 20% infill, right? So if we wanted higher strength, we could go for 50% infill or higher. If you go for 100% infill, it will obviously be the strongest, but it will use a lot of material and it will take a lot of time, right? And other methods of manufacturing it would nearly be better at that stage. Okay, so it's this percentage infill that allows us to 3D print parts relatively quickly. Okay, but it is a trade-off between strength and speed and weight, okay, and the amount of material we use. At the top, then, it has to do a few solid layers on top of those triangles. So if we didn't have any material in there, if this was zero, right, we would now have no triangles in here. We'd have nothing to help support the top surface. So that's important, and that's why we do need to put some material in there in the form of a mesh. Okay, so if we go up here, you see there's our solid layer, right, and we have 3 or 4 solid layers. The more we add, the better a finish we'll have on our top surface. If we only had one layer, you would have little gaps and imperfections, and it would probably be a bit bumpy, where the lines of material would kind of sag between the triangles. Okay, so that's why we have those mesh, and that's a quick overview of a 3D printed part, right? So if we go back and we look at our steps, right, we had step 3. I've probably covered step 4. I have. So slicing the model, right? I've looked at some settings. We'll look at a little bit more in a minute. And step 5 is to save that file and send it to the printer, right? So what we need to do now is we need to save this file in a format that the 3D printer can read, right? And when we save it using this button down here, but when we save that, that's just a set of instructions. It turns all of these individual slices into instructions for the printer. So the speed at the motor, the temperature of the material, okay? What pattern it should follow. So it'll follow these lines. It'll tell it what order to do all of these different things in, okay? So when we press this and we save that file, we can't edit it, right? It's not a file that we can alter. So the best thing to do now is to save this project file separately. So save project, right? And you can just save this, right? And it saves it as Ultimaker 3 Extended or UM3E Cube, okay? So that tells me the printer name and the part name. And I'm just going to press save. So now if I look at that part and I want to make changes, I can go in here and I can edit this file, okay? Okay, so once you have that done, we'll then save our instructions for the 3D printer, and that's called a G code. Okay, so that's the name of the type of file, and basically it turns this image that we have used into written instructions for the computer, right, on the 3D printer. So we save that, and again, it's going to call it UM3E Cube, but this time it's called a G code. Okay, so save that. And that's this one here. So that will appear as a Cura file, but if I try and open that by double clicking, it's going to tell me that it's a G code file and I can't edit it. Okay, so it says there, G-code details. Make sure the G-code is suitable for your printer and the printer configuration before sending the file to it. The G-code representation may not be accurate. So that's just a message. I don't have any options, so print setup disabled, G-code file cannot be modified. So this is the file that I'm sending to my 3D printer, and I can again preview all of this. So I can press play here and I can see what the printer will actually do. Right, I could have done this on my main file as well. So we actually see exactly how the 3D printer will print the individual features. Right? So this can be very useful if you print something in a 3D printer and it fails the first time. So you can go back and see, well, what order should it have printed in, right? Where does that correspond to the way my printer failed, right? And you can maybe alter the order in which they're done. So we could look at, we won't leave that play, but we can look at other layers. If we look at one of the meshed layers, it'll be a bit quicker. So it's printing the infill. Okay, again, that's 20%. And it's now going to print the walls. Okay, so that's the name obviously for the outside layers. So you can change the number of walls that you have set. I think we have 4 in this one, and now it's going on to the next layer. Okay, so we won't do anything here, we'll just close that down. Okay, so that's a basic part, right, created in 3D CAD, taken through the whole process, and we could now just transfer, right? So all we would have to do now is take this part here, transfer that to my USB stick, and take it to my 3D printer. Or maybe some 3D printers have network connections where you would just be able to drag and drop this onto the 3D printer. Okay, so that's all we need to cover in this video in terms of the basic operation.